The Galileo myth. Galileo happens to be surrounded by myths. He lives in a cloud of fabricated myths. He did not invent the telescope, he improved it. He did not start the theory of heliocentrism, he used Copernicus' system. He did not prove heliocentrism, he couldn't. He was not silenced by anti-scientists in the Catholic Church. He did not mutter, and yet the earth moves, as far as we know. He was not tortured by the Inquisition. He was not even incarcerated by the Inquisition. These are myths, so let the real Galileo stand up. What was the problem? Aristotle had proclaimed the earth as in the center of all the other planets. Geocentrism. The alternative that Galileo was promoting was that the sun is in the center, heliocentrism. He learned that from Copernicus. What is the problem with either system? The retrograde motion. When you look at the sky night after night, you see, for instance, Mars move forward, but sometimes it moves backwards for a short time. How do we explain that? In either system, Ptolemy solved it by introducing what we call epicycles. Those are cycles on cycles, and thanks to those epicycles we are able to explain retrograde movements, as you can see in this animation. So he was able to explain retrograde. But Copernicus could too, of course. But he did it in a different way, and both ways seem to work nicely. When you look at it, they both acknowledge retrograde. So what is the better system? It's hard to tell based on this evidence. But the problem with heliocentrism is that it's counterintuitive. We see every morning the sun rise and set at night. For centuries, people who navigated the seas had used his system, and astronomers were able to predict eclipses by using that system. And if the earth moved, then clouds would be left behind, wouldn't they? Even Galileo acknowledged that. And then there is the famous so-called tower argument. Objects appear to fall vertically on Earth rather than diagonally. And besides, another big problem is those new telescopes. Did they show artifacts or real facts? As I said already, they have equal accuracy. Either system can explain the situation well, but they do it in a different way. So it's hard to decide what is better. But Galileo said Copernicus is the winner. And he had some reasons for that. He used his spyglass that he borrowed from the Dutch and improved it, and he saw spots on the sun that revealed the rotation of the sun. But was that proof for heliocentrism? Not really. One of the biggest problems with heliocentrism is how do you prove it? Galileo said the tides are proof. Everyone said it at his time that was absolute nonsense. But he had another argument which sounds very good. That is, the phases of Venus are similar to the phases of the moon. So apparently there is a rotation around the sun. But was that conclusive proof? He could not really answer the strongest arguments against heliocentrism. The problem of stellar parallaxes. They were not observable at the time. So later on that would be discovered, but not at the time of Galileo. So that was not a good proof, and this lack of evidence gave the famous astronomer Tycho Brahe reason to do away with heliocentrism. So let's look at the timeline. After Ptolemy, we had to wait a long time, and then Galileo was surrounded by famous astronomers, but they had different opinions about the heliocentric system. Galileo was well aware that there was lack of evidence. He could not prove the motion of the Earth, so it was a hypothesis in need of further proof. But he was so determined to promote heliocentrism that he was probably blind for any problems, according to Albert Einstein. What did Galileo conceal? He concealed that there were at least two other very respectable models: the geocentric model of Tycho Brahe, the heliocentric model of Johannes Kepler. Kepler assumed that there were ellipses and not circles, like Copernicus and Galileo did, and Kepler was right on that issue. Let me explain the tectonic model. The moon and the sun revolve around the Earth, which is basically geocentrism. But the other planets move and revolve around the sun. So he combined helio and geocentrism. It was a very respectable theory. But the fate of it was, though they were both mathematically identical, that Tycho would finally lose the battle when Newton launched his theory of gravity, but that was much later. Unfortunately, Galileo deliberately ignored the tectonic system, because he was very well aware that there was no evidence that the Earth moves. So it was a vision, not a proof. When he published a book in 1632, he supported the Copernicus system and ignored Brahe's geocentric model and Kepler's heliocentric model. We know now that Galileo was partly right, partly wrong. Was the Church against heliocentrism, as is often claimed? Definitely not. Thomas Aquinas, almost 3 centuries earlier, had already noticed that the movements that we see are the result of the motion of the object seen or the motion of the observer. In other words, the sun could be moving or we could be moving. Aquinas noticed that already long ago, and he said all the suppositions that were invented need not be necessarily true, but they save the appearances under these suppositions. Something similar was said during the time of Galileo by Cardinal Bellarmine. He said there is a mathematical astronomy that saves the appearances, and there is a physical astronomy that claims the physical structure of the heavens. But any astronomical theory may be saving the appearances, but not necessarily revealing what is the case in reality. Interestingly enough, Jesuit astronomers initially supported Galileo, though they also adopted a halfway house, the system of Tycho Brahe, which was very respectable. Still, Galileo enjoyed a long audience with the Pope in Rome and with the Jesuits of the Roman College. He met Father Greenberger and Father Clavius, who were very favorable to his ideas, and Father Clavius even used the Copernican system for his Gregorian calendar. But gradually he lost strong support from the Jesuits because he got embroiled in various controversies with those astronomers. One was about comets, and Father Grassi was on the right side of the dispute. He also had a dispute with Father Scheiner about the discovery of sunspots. By all these controversies, he helped cement the Jesuits' opposition to Galileo gradually. But let's stress, he was not condemned for heliocentrism, but for declaring it an established fact instead of a hypothesis. and he could not establish that fact. Besides, and that is more serious, he decided to venture into theological territory. The Church had always encouraged the work of Copernicus and Kepler, but now there was a theological issue at stake that goes far beyond the question of mere celestial mechanics. Yet Galileo asked the Church to back him for his scientific claims. But the Church does not deal with disputes in science, but with controversies in theology, such as heresies. So the inquisitors followed proper procedure by requesting expert opinions, but the scientific community was divided herself. What was the right model? In a 1616 verdict by the Inquisition, there were two separate declarations. First of all, his theory not behold on purely scientific basis, and besides it's also heretical in purely scriptical terms. So his heresy was not heliocentrism. He was trespassing on theologians' territory. He was an expert in cosmology and physics, but certainly not in theology. His friends in Rome had warned him, but he wanted to go into a debate on theological grounds. He entered with no expertise in a discussion on the proper mode of interpreting Scripture. That was dangerous at that time, because there were other people, lay persons like Martin Luther and Johannes Calvin, who wanted to reinterpret the Scriptures. And now Galileo was doing something like that. He was a driven ideologue. He claimed more evidence than he actually had. But he was intent on ramming Copernicus down the throat of Christendom. Though he had many friends at the beginning, he alienated almost everybody with his caustic manner and aggressive tactics. It gave the Church authorities no room to maneuver anymore. In short, he was not a tactful person. He loved to score off people and make them look stupid. Finally, he was allowed to return to his villa near Florence, under house arrest. As Alfred North Whitehead put it, in a generation which saw the 30 Years' War and remembered Alva in the Netherlands, the worst that happened to men of science was that Galileo suffered an honorable detention and a mild reproof before dying peacefully in his bed. Yes, he died peacefully in his bed, in spite of Voltaire's line that Galileo groaned away his days in the dungeons of the Inquisition. That is a complete fabrication from someone anti-church, anti-Catholics. And so is this one-liner, and yet it moves. We have no indication that Galileo uttered this sentence. In fact, Galileo was never tortured, never sentenced to death, never imprisoned. His penalty was house arrest at a pleasant villa near Florence. He was not condemned by the Church for his astronomy. He was condemned for proclaiming himself an expert in theological matters and for promoting a theory as certain, true and proven, without enough scientific evidence. I discussed this issue much more detailed in my book 5 Anti-Catholic Myths that you can find at angelicopress.com. It discusses 5 myths: slavery, crusades, Inquisition, the Holocaust and Galileo.